Well, well. What is the Laplace transform L of a function of t? This one is equal to the semi-infinite integral from 0 to infinity of that function of t exponential negative st dt, where s is positive and it's positive such that this integral converges. That is basically the definition of Laplace transform of any function. So what is the Laplace transform of A? Where A is a function, is a constant. So this is from 0 to infinity, where ft is, replace it with A exponential negative st dt. A is a constant, so we can put it outside the integral from 0 to infinity exponential negative st dt. This is a bound integral, or we can call it a definite integral. Remember, if I integrate from a to b, k exponential at, or we can put this constant here as pt with respect to t, then this one becomes k over p exponential pt plus constant. Then we integrate it from a to b. Remember that now it's going to resolve because we have limits. Now if you look at it like this, then we have a into bracket, my k is a, my p is negative s, so we have negative 1 over s exponential negative st. I substitute the boundaries from 0 to infinity. Now what I do is take this fraction, which is also a constant, outside 1 over s, then I can have it like that, and I have exponential negative st from 0 to infinity. Now substitute infinity for t, substitute 0 for t. Get the difference between the two substitutions. So we have negative a over s into, first substitute the upper limit, we get exponential negative infinity. Because when you compare infinity and s is much smaller than infinity. So the whole evolution becomes negative infinity. Then I subtract exponential, I substitute here for t is 0. Negative s times 0 gives us 0. So this exponential becomes our 0. So this one becomes negative a over s into, if I take exponential to negative infinity, I get 0. And I subtract exponential 0. Any number raised to 0 is 1, so this becomes 1. And I multiply here, I'll get 0. And I multiply here, I'll get positive a over s, and the whole Laplace transform of that constant a becomes a over s for all values where s is greater than 0. Otherwise, it will not converge. So s should be greater than 0 for this one to evaluate. And that is the Laplace transform of a constant a. So if I ask you to get the Laplace transform of a number like 8, a is 8 in this case, so this becomes 8 over s. If I ask you to get the Laplace transform of a third, let me put it properly here, a third. So a is a third, this becomes a third over s. So basically, the Laplace transform of a function of t is the semi-integral from 0 to infinity of that function of t with respect to t exponential negative st, such that now, if the original function was a function of t, the Laplace transform converts it into a function of s, just like this one. We Laplace transformed a constant from being a function of t, now it is a function of s. So the Laplace transform transforms a function of t into a function of s, and that is important. You're not breaking back. Laplace transform, that is the definition. It is a constant, that is the procedure you follow. So the Laplace transform of a constant is a over s. Next, we will look at Laplace transform of functions here and there before we go into it.